Welcome back to the class on a power semi-connected drive. In this class, we are going to discuss about the multi-quadrant operation of a DC shunt motor with a DC to DC converter. Initially, we are going to discuss about the two-quadrant operation of the shunt motor. How we are going to achieve the two-quadrant operation by means of a DC to DC converter. Nothing but a both motoring as well as a regenerative breaking. Next, we are going to see the four-quadrant operation of the DC shunt motor with a DC to DC converter. This is a circuit diagram for the two quadrant operation of a DC shunt motor. This is the source. Here we kept a one capacitor to maintain input voltage constant. Sometimes this capacitor also will be stores the energy when the DC motor is giving a power back to the source. S1, S2. S1, S2 are the nothing but a control switches. In place of S1 and S2, we can use the BJT as a MOSFET or IGBT. D1, D2. This is feedback diode. This is a freewheeling diode. This is the load, nothing but a DC motor. In place of DC motor, we simply keep it as a one resistance inductor as well as a backplane. This is nothing but RA. This is nothing but LA. This is a AB. The voltage across the armature of a DC motor that we define as a V. This is the positive direction of the load current. If you observe here, on the x-axis we have taken the current, on the y-axis we have taken the voltage. Nothing but a load voltage and load current is positive. Nothing but load power becomes a positive. The power is passing from the source to the load. In the second quadrant, the voltage is positive where the current is negative. So the load power becomes a negative. Nothing but this motor is giving a power to the source. For getting the first quadrant operation, you have to operate only the S1. Don't give any firing pulses or base voltage. When S1 is closed, now the current is passing from source S1 load return to the source. Nothing but load voltage is equal to source voltage. This is the one mode of operation. When S1 is off, already S2 is off. Now the current is passing from the load to the D2, again return to the load. Nothing but there is freewheeling action taking place through the D2. This is given the first quadrant operation. Now we are going to see how do you achieve the second quadrant operation. Already we have seen the regenerative braking. The regenerative braking is nothing but a second quadrant operation. S1 is off. Now we are going to operate the S2. When you are operating S2, now the current is passing load S2 again return to the load in this manner. In this interval, there is some amount of energy will be stored in the inductance of a motor. So whenever the S2 is off, now the current is passing from motor D1 supply again return to the motor in this manner. So in this case, whatever the energy stored previously in this motor, that power is given back to the source through the D1. If you observe the two cases when the S2 is on and the S2 is off, the direction of the current, actual current is passing opposite to the reference, but the voltage is positive. So power becomes a V0 becomes a V0 into I0. This is positive, but this is negative. The power becomes negative. So whatever the electrical energy given by this motor, that is given back to the source, where the capacitor is kept, that energy will be stored in the capacitor. Nothing but it gives the regenerative braking to the, which is representing this second quadrant. Generally, we are using this circuit for the servo motor drives where motoring, braking also required. There is a fast transition between the motoring as well as the braking is required. So by that time we can go for the this circuit, which gives the two quadrant operation for the DC shunt motor. Now we are going to see the four quadrant operation of a DC shunt motor. This is circuit diagram which is given the four quadrant operation for the DC shunt motor. This is the armature motor. This is the field winding. This is S1. This is S2, S3, S4. D1, D2, D3, D4 are the diodes which are connected anti-parallel to the S1, S2, S3, S4 respectively. This is the input voltage that we have taken as a VDC. Sometimes we can take it as V also. Here we can keep one capacitor so that the motor is giving a power back to the source. Then the energy will be stored in the capacitor. On the x-axis, we have taken the load current. On the y-axis, we have taken the voltage. In the first quadrant is nothing but a forward motoring. So how we are going to achieve the forward motoring means of the S3 and S4. Nothing but don't apply any pulse to the S3 and close the S2. Operate the S1. When you are operating the S1, when S1 is closed, now the current is passing from S1 armature of the DC motor. S2 is already closed. So in this manner, the current is passing through the S2. The actual current is same as the load current, reference direction of load current. So current is positive, the voltage also the positive, because the positive is connected here, this negative terminal is connected to the negative terminal to the. When the S1 is off, now the freewheeling action should be taken place because S2 is closed. Now the current is passing through the load S2 D4 again return to the load in this manner. In this case also the load current is positive, where the voltage is 0. So it is given the first quadrant operation. And during on of S1 and off of a S1, the power is always passing from the supply to the load. So it is nothing but a first quadrant operation. The motor will be rotating in one direction. In the second quadrant operation, we are offing the three switches. S1 is off, S3 is off, S2 is off. Operating the S4. When the S4 is closed, now the current is passing in this manner. Motor S4 D2 again return to the motor. The actual current is opposite to the reference direction what you have taken in the circuit. Current becomes a negative. In this interval, the current is increasing from the minimum value to the maximum value. The amount of energy will be stored in the inductance. When S4 is off, now the D1, D2 is forward bias. Now the current is passing in this manner. Motor D1 supply D2 again return to the armature SI motor. When the S4 is on and off, also the current is passing opposite to the reference, nothing but a load current is a negative value, voltage becomes a positive, but current is negative, which is represented in the regenerative braking in a forward motoring operation. Now we have to rotate the motor in a opposite direction. To rotate the motor in opposite direction of the S1 and don't apply any base voltage to the S1 and S2. Close the S4. Operate the S3. At the moment we are owning and offing the S3. When you on the S3, at the moment it is closed here. Now the current is passing from the supply S3 in this manner. Load S4 again return to the supply. The load voltage becomes a negative because this positive is connected to the negative, whereas the negative is connected to the positive of armature. Voltage is negative. Current is also negative because the current is passing opposite. So both quantities are the negative. Suppose if S3 is off, there is a freewheeling action will be taken place. Now this current is passing load S4 D2 again return to the load in this manner. So when the freewheeling action is taken place, the voltage across the armature becomes 0, but the actual current is opposite is reference, the current is negative. So when the S3 is on, current is negative, off also the current is negative. So the average load current becomes a negative, the voltage also the negative, power becomes a P0 equal to V0 into I0, power becomes a positive because both are negative. When the power is positive, nothing but this motor will be rotating in a opposite direction. Why it is opposite means the actual current is passing opposite to the reference. Previously, if the motor is rotating in one direction, motor will be rotating in a opposite direction. That is represented in the third quadrant operation. Now, if you see the fourth quadrant operation, nothing but a regenerative braking in a reverse direction. To get the regenerative braking in a reverse direction, operate the S2, S1, S3, S4 is off. When the S2 is on, now the current is passing load S2, D4, then return to the motor. In this interval, whenever the energy is stored in the inductance of a motor, when the S2 is off, now D3, D4 is forward bias. Now the current is passing motor D3 supply, D4 again return to the motor. When S2 is on, the motor current is positive. When the S2 is off, also the motor current is positive. The current is positive, but the voltage becomes a negative. Why it is negative means, see here, this positive is connected here, whereas the negative is connected. So the load power becomes negative, which exactly represents in the regenerative braking of a DC shunt motor in a reverse direction. So in this manner, by properly operating these switches, you can get the four quadrant operation for this DC shunt motor. The physical meaning of the four quadrant operation is nothing but a forward motoring, braking in a forward direction, reverse motoring, braking in a reverse direction. So thank you very much. If you have any doubt, you can ask me directly, or you can ask in the comment box of the YouTube channel, so that I am always available to answer all your